Hi everyone. Today we're going to study Affine Cipher. We can generalize shift cipher further to slightly enhance security. By using a function of the form f of p is equal to the quantity ap plus b, then mod 26. Where a and b are integers such that f is a bijection. The function needs to be a bijection, otherwise we could not decrypt the cipher. The function f of p is equal to the quantity ap plus b. Mod 26 is a bijection if and only if the GCD of a, 26 equals 1, meaning this a and 26 are relatively prime. Such a mapping is called an affine transformation, and the resulting cipher is called an affine cipher. How to find the decryption function? Let the encryption function be the f of p is equal to the quantity ap plus b mod 26, where GCD of a, 26 equals 1. This is the affine transformation. Since GCD of a and 26 is equal to 1, a has an inverse modulo 26, say a bar. That is, a bar times a is congruent to 1 mod 26. Given our encryption function, now we let f of p equals c. So we can replace the c in here. So the new function becomes c is equal to the quantity ap plus b, then mod 26. For decryption, we know the value of c, and we have to express p in terms of c. For that, we have to solve the congruence c is congruent to ap plus b, mod 26. We can rewrite this congruence into like this. We interchange the c and the quantity ap plus b. So the left side will be the ap plus b is congruent to c mod 26. Let us transpose this positive b on the right side. So we have ap is congruent to c minus b mod 26. Next, we're going to multiply both sides of the congruence by the inverse, or a bar. A bar times ap is congruent to a bar times the quantity c minus b mod 26. This a bar and a will cancel each other, or it becomes 1. So we have 1 times p. Then we can remove this number 1. So we have this p is congruent to a bar times c minus b and mod 26. With this congruence, we can translate it back into equation. So we have this p is equal to a bar times the quantity c minus b mod 26. This is now the decryption function. Note here that the c is the number associated with the encrypted cipher. Let us see example 1. Encrypt the message "Thank you" by affine transformation. F of p is equal to the quantity 15p plus 13 mod 26. For step 1, we translate each letter to the corresponding element of z sub 26. Again, we have this alphanumeric table. The word "thank you" is here, and the corresponding numbers for each of the letters are 19 for T, 7 for H, 0 for A, 13 for N, 10 for K, 24 for Y, 14 for O, 20 for U. Step 2. Replace each of these numbers P by the function f of P is equal to the quantity 15P plus 13 mod 26. We can start with the number 19. So we will do like this. 15 times 19, then plus 13. Simplifying this using our calculator, the value is 298. Then we take mod 26. When we divide 298 by 26, the remainder is 12. So for the number 19, the equivalent is 12. So we write it here. We will use this pattern for the remaining numbers. So for 7, it becomes 14. For 0 is 13. 13 is 0. 10 becomes 7. 24 becomes 9. 14 becomes 15. 20 becomes 1. For step 3, we translate this back to letters to get the encrypted message using this alpha numeric table, meaning the number 12 corresponds to letter M, 14 is O, 13 is N, 0 is A, 7 is H, 9 is J, 15 is P, 1 is B. This is the final answer. Example 2. Decrypt the message MONAH space JPB by affine transformation. F of P is equal to the quantity 15P plus 13 mod 26. The step 1 here is to find the decryption function. Here is our function that we derived a while ago. So this is P is equal to A bar times the quantity C minus B, then mod 26. A bar here is the inverse of A modulo 26. Here the A is equal to 15 and B is 13. Since GCD of 15 and 26 is equal to 1, we can find the inverse of 15 modulo 26. So step 2, we're going to look for the A bar or the A inverse. We write here 15 times A inverse is congruent to 1 mod 26. So in here, we're going to find for an integer A bar such that when multiplied by 15 and the product is divided by 26, the remainder must be 1. We can use trial and error. Let us use our calculator and look for that specific integer. So in this case, the A bar is equal to 7 because this 7 multiplied by 15 and the product is divided by 26, the remainder is 1. Step 3. Now we substitute the values of A bar and B to the decryption function. This is our function. So it becomes like this. P is equal to 7 times the quantity C minus 13 mod 26. Let us copy this new function on top here. Now let's go to step 4. Translate each letter to the corresponding element of Z sub 26. We're going to use our alpha numeric table. The message is given as this. Now, the corresponding numbers for each of the letters are here. 12 for M, 14 for O, 13 for N, 0 for A, 7 for H, 9 for J, 15 for P, 1 for B. Then step 5, replace each of these numbers. Let's begin with the first number, 12. So it becomes like this. 7 times the quantity 12 minus 13. So the answer is negative 7. Then we take the mod 26. Let us convert this negative 7 into its equivalent positive integer. So this 26 plus negative 7, we will get this 19. Then we write again mod 26. And the answer here is 19. Meaning, for number 12, the equivalent number is 19. So we write it here. We're going to use this pattern to the other numbers. So 14 becomes 7, 13 becomes 0, 0 becomes 13, 7 becomes 10, 9 becomes 24, 15 becomes 14, 1 becomes 20. Step 6, we translate this back to letters to get the decrypted message. So the letter corresponding to 19 is T. For 7 is H, 0 becomes A, 13 is N, 10 is K, 24 is Y, 14 is O, 20 is U. So the message is thank you. This is the final answer. I hope you learned something from this video. See you again next time.